What if everything you think you know about reality is wrong? A question that has echoed through the corridors of time, challenging our perceptions and beliefs. From the dawn of our species, we've been trying to make sense of the world around us. Our ancestors, those early humans, viewed reality through the lens of their immediate environment and experiences. Picture this. The world of the early human was small, confined to the regions they could traverse. They interpreted reality based on what they could see, touch, hear, or smell. Natural phenomena that we now understand as weather patterns, tectonic activities, or celestial movements were perceived as acts of supernatural entities. Thunder was the fury of gods, earthquakes their displeasure, and the changing seasons were proof of their divine whims. As time passed, humans started to question their reality. They began to observe, to question, to deduce. They started to see patterns in the chaos, laws in the randomness. This shift from supernatural to natural, from divine intervention to scientific reasoning, was a monumental step in our understanding of reality. The Greeks, for instance, began to understand that the world was governed by natural laws, not the whims of the gods. They deduced that the earth was round, not flat, and even estimated its circumference with remarkable accuracy. This was a radical shift in perception, a testament to the power of human curiosity and our relentless pursuit of knowledge. However, even as our understanding of reality grew, so did our misconceptions. The Earth at the center of the universe, the sun revolving around us, time being an unchanging constant, these were all notions that were widely accepted until proven otherwise. It's almost amusing to think how certain we were of these realities, only to have them shattered by the relentless march of scientific discovery. But as we progressed, our understanding of reality took a dramatic turn. We are now faced with a new paradigm shift, the realization that our local reality might be false, and the startling proposition that consciousness could be the fundamental building block, not space-time. As we continue to probe the realities, it's clear that our journey is far from over. Remember when we believed the Earth was flat? Well, not us exactly, but our ancient ancestors. They looked around and saw a flat landscape, so they naturally concluded that the entire Earth must be flat too. It's an understandable mistake, given the limited observational tools they had at their disposal. Let's go back in time, to when the belief in a flat Earth was as common as the air we breathe. Ancient civilizations across the globe, from China to Greece, held this belief. They thought the Earth was a flat disk, surrounded by an immense, possibly infinite ocean. But then an ancient Greek philosopher named Pythagoras came along. Around the 6th century BC, he proposed a mind-blowing idea. The Earth was not flat, but spherical. Pythagoras noted the shape of the Earth's shadow on the moon during a lunar eclipse, round, not flat. This was one of the earliest arguments in favor of a spherical Earth. But it was another Greek, Eratosthenes, who really turned the tides. He was the chief librarian at the Great Library of Alexandria, and he devised a simple yet brilliant experiment. Eratosthenes noticed that at noon on the summer solstice in the city of Syene, the sun was directly overhead and cast no shadow. But in Alexandria, several hundred miles to the north, vertical objects did cast a shadow at the same time. Using the difference in shadow lengths and the distance between the two cities, he calculated the Earth's circumference with remarkable accuracy. This was a pivotal moment, a true paradigm shift. The Earth was not a flat disk, but a round sphere, spinning on its axis and orbiting the sun. The implications were profound, affecting everything from navigation to our understanding of our place in the universe. And just like that, our reality was flipped, or rather, rounded off. And what about the time we thought the sun revolved around us? A common misconception for centuries was that the Earth was the center of the universe. This was known as the geocentric model, where all celestial bodies, including the sun, were thought to revolve around our planet. It was an idea rooted in our daily observations. After all, doesn't the sun rise in the east and set in the west? However, as the scientific method began to shape our understanding, a radical shift occurred. Enter Nicolaus Copernicus, a man who dared to challenge the established norms. He proposed the heliocentric model, the concept that the Earth and other planets revolve around the Sun. This was a revolutionary idea, and it was met with a fair share of resistance. After all, it was a radical departure from the accepted understanding of the universe. Despite the initial resistance, the heliocentric model began to gain traction. The observations and mathematical models of Johannes Kepler, along with Galileo Galilei's support for the theory, helped cement the sun-centered model as the new paradigm. Galileo's use of the telescope, a novel invention of his time, allowed him to observe celestial bodies more closely. His observations provided solid evidence that the Earth was not the center of the universe. This shift to the heliocentric model was more than just a scientific breakthrough. It was a philosophical upheaval. It challenged our understanding of our place in the universe. We were no longer the center stage, but just another planet revolving around a star in the vast cosmic theater. The transition from a geocentric to a heliocentric model is a testament to our ability to question, to seek answers, and to change our perspective based on new evidence. It's a reminder of how our understanding of reality can be faulty and how it can evolve over time. Once again, our understanding of reality was radically changed. And as we'll see, this wouldn't be the last time. Scene script. Ever thought time was absolute? Think again. Dive into the world of relativity, and our understanding of time takes a truly mind-bending turn. For centuries, we perceived time as an unalterable flow, ticking away universally at the same rate for everyone, everywhere. But enter Albert Einstein, and our understanding of time was turned on its head. Einstein's theory of relativity, proposed in the early 20th century, brought a revolutionary viewpoint to the table. Contrary to the popular belief of time being absolute, Einstein proposed that time is relative. Now, what does that mean? Simply put, time can slow down or speed up depending on how fast you're moving or how far you are from a mass. Let's break this down a bit. Imagine you're on a spaceship, traveling close to the speed of light. Back on Earth, your friends are going about their daily lives. According to Einstein's theory, time would pass slower for you on the spaceship than for your friends on Earth. When you return, you might find that while only a couple of years have passed for you, decades have passed on Earth. This isn't science fiction, it's science fact, a phenomenon known as time dilation. Similarly, gravity also influences the passage of time. Time ticks slower the closer you are to a massive object, due to the effect of gravity. So theoretically, if you were hanging out near a black hole, time would pass slower for you than for someone in a less gravitational field. Einstein's theory of relativity, with its concept of time dilation and gravitational time warping, has been tested and proven time and again, and it has fundamentally changed our understanding of the universe. We've realized that time, like many other things, isn't absolute, but relative to the observer. So we learned that even time isn't what it seems. But what if the most fundamental thing we know, space-time, is not the ultimate reality? This question may seem outlandish to some, but it is a query that's been making waves in the scientific community. Let's dive into the world of quantum physics, a realm that is just as mysterious as it is fascinating. It's here that scientists are beginning to ponder the possibility that space-time, the fabric of our perceived reality, might actually be emergent from something even more fundamental: consciousness. Here's a little food for thought. Quantum theory suggests that particles do not have definite states unless they're being observed. Strange, isn't it? The act of observing appears to force a particle to settle down into one state. This has led some scientists to propose that consciousness could be deeply connected with the nature of reality. Now let's delve a little deeper. Some theorists are suggesting that our reality is not a standalone physical entity. Instead, they propose that it's a mental construct born from consciousness. In this view, space-time is not the stage on which the cosmic drama unfolds, but rather, it's a part of the script itself, brought into existence by the actors. That's us. This idea challenges everything we thought we knew about the universe. It suggests that we are not mere spectators in the cosmic theater, but active participants who help shape the reality we inhabit. But what does this mean for us? If consciousness is the fundamental building block of reality, then our understanding of the universe and our place in it could be turned on its head. It's a daunting concept, no doubt, but also an exhilarating one. It opens up a new way of looking at the universe and our role within it. So, are we ready for another shift in our understanding of reality? It's a question that's equal parts thrilling and terrifying. But one thing's for sure, the journey to unravel the mysteries of the universe is far from over. So, what have we learned today? We've journeyed from a flat Earth to a globe, placed the sun at the universe's center, and discovered time's relativity. We've wrestled with the idea that reality, as we perceive it, may not be as local or as simple as we once believed. And now, we're exploring the intriguing possibility that consciousness, not space-time, forms the bedrock of our existence. As our understanding evolves, reality will continue to surprise us. After all, reality is not what it seems.